if I have the integral 1 over square root of 1 minus x squared dx. Okay, the formula right here, right? The formula, we don't have any formula of this one. Right? We don't have any formula of this one. But think about like if I set like x, if I set x right here equal sine theta. So what happened? If I set x right here equals sine theta. So when I put the sine theta to here, I have 1 minus sine squared theta. So square root of 1 minus sine squared theta is just equal cosine theta, right? Yeah. And also I have like, if I set s equals sine theta, right? So dx is just cosine theta e theta. So you will have like cosine theta, you divide by cosine theta, you want to cancel out. So the integral right here, it just become like d theta. Yeah. That is the idea. Because like in this integral, you have a square root, of 1 minus x squared. So we need somehow to convert this integral to become the new integral without square root. And the idea is we're going to use this formula right here. Okay, so let me show you step by step. So if you let x equal sine theta, right? So dx is just cosine theta d theta. Right? So the integral right here, it just become, you have dx right here. Then dx equal cosine theta e theta. So you replace dx by cosine theta d theta. So cosine theta d theta over square root of 1 minus x squared. Square root of 1 minus x squared, it just become 1 minus sine square of theta. So I keep the top. Square root of 1 minus sine square theta is just cosine theta, right? That one is just cosine theta. So you can cancel out that one, right? So that one, it just become d theta. The integral of d theta is just theta plus c. Right? And also because you have s equals sine theta, so theta gonna be equal sine inverse of x. So that means the integral right here, you replace theta by sine inverse of x. So the final answer is sine inverse of x, then plus c. Okay, does that make sense for you? Recall that we learned the substitution already, right? The idea of substitution method is you want to convert the integral that you don't know how to evaluate become the new integral that you know how to evaluate. So the idea is from beginning, you have this integral. We don't have any formula, right? But after we do like trig substitution by you set like x equals sine of theta, you will be able to convert this one become to something is just integral of d theta. It's just theta plus c. Yeah, it's something that you can evaluate. Okay, if no question, let's move to the sample for tangent. So if I have like the integral of x squared plus 1 dx, you don't have any formula to evaluate that one because like that one is x squared plus 1, not x plus 1. If the integral right here is just x plus 1, we have formula, right? It's just ln of x plus 1. But that one is x squared. We don't have any formula of that one. So the idea is we will use this one. We will use the thing here. You see, tangent square theta plus 1 is just equal secant square theta, right? So think about like if I set x right here equal tangent theta. So if I set x equal tangent theta, so x squared plus 1 is just tangent square theta plus 1. So it's just equal secant square theta. And also if I set x equal tangent theta, so dx is going to be equal secant square theta d theta. So the top we have like secant square theta d theta, and the bottom we have secant square theta. So secant square theta divided by secant square theta is just 1, right? So after that, you just have like the integral of d theta. Let me show you step by step here. So for that one, we set x equal tangent theta. So dx is going to be equal secant square theta d theta, right? And the integral right here, you apply dx here, right? The integral, we have dx, and dx is just equal secant square theta d theta. So I put in secant square theta d theta. Right. That is the top, the numerator. The denominator, I have x squared plus 1. X squared plus 1 now is equal tangent square theta plus 1. I keep the top. Tangent square theta plus 1 is equal secant square theta. Right. Because like, I have this formula right here. So I can divide by, I can cancel out that. I can get like integral of d theta. Right. So integral of d theta is just theta plus c. And because like I said x equal tangent theta, so theta is tangent inverse of x. So that one is just equal tangent inverse of x plus c. Okay, that's just like two types of Trig substitution. So whenever you see like square root, the square root of the number, you minus the variable square. So we will use the sine theta, right? And whenever you see like the square variable, then you plus a number, we will use the tangent theta. Just two types of the trig substitution. Any question for problem we just did. Any question? The last one. It mean like you mean like repeat the whole problem too, or just the last step? The last step. Yeah. So I can repeat the whole problem. Okay. So the problem is 1 over x squared plus 1 dx, right? So the idea is you want to convert this integral to become the new integral that we know how to evaluate, or maybe it's easier to evaluate. So I said x equal tangent theta, right? So we have dx. So we need to convert dx to d theta, right? So dx is going to be equal secant square theta d theta. So I replace dx here by secant square theta d theta, right? So dx is equal secant square theta d theta. Also, I have x squared plus 1 now. This one is just tangent square theta plus 1. Tangent square theta plus 1 is equal secant square theta. Right. So the top you have secant square theta d theta. The bottom you have secant square theta. So you can cancel out, right? You can cancel out. Now the integral, it should become the integral of d theta. So what is the integral of d theta? It's just theta plus theta. Think about like similar to like integral of dx, like 1. Nothing is just 1, right? It's just x plus c. Similar to integral of d theta. Okay, it's just theta plus c. And because like you said, because like the question gives you x, so you need to give the answer in x, not theta, right? Like remember, like when you do substitution, after you convert to the new variable, after you find the antiderivative, you need to like convert back to the original variable. So the question gives you the variable x. You cannot give the answer at like at u at theta, right? You have to give to the answer of the problem by variable x. So similar to that, you need to convert back to x. And because x equal tangent theta, so theta is equal tangent inverse of x. Or maybe you can write like arctan. Maybe you can write like arctan. It's same thing. The arctan and the tangent inverse is the same thing. Same thing. The arc sine and the sine inverse is the same thing. So you have theta equal tangent inverse x. That's why like theta right here, you reply by the tangent inverse x. And that one is the final answer. Same thing with like the problem 1, that one is the final answer. Okay, that makes sense now. Yeah. Any other question? If you have no question, let's move to the other example so you can have like make more sense with the other example. Like if I give you this one, the integral from 0 to 1 of 1 over 4 minus x squared dx. Okay, how we can deal with this problem? So remember, like we only need to know 2 types of the Trig substitution, which is sine theta and tangent theta. So in this case, you use sine or tangent. Anyone? For this problem, we use sine theta or tangent theta. Sine, right? Right. Because like I say, you have like square root of the number minus square of variable. You're gonna use sine. Because like you have like square root of 1 minus sine square theta equal cosine theta. So you need to get out like the square root here. Okay, but the thing is, remember like when you use this one, you need number one here, right? Cosine theta equals square root of 1 minus sine square theta. So this one we need number one here. We need a number equal 1. But in this case, the number is equal 4. Right. So we need to modify a little bit. Number 4 right here become 1 by factor out. If I factor out inside the square root, I factor out 4, right? So I will get like 1 minus x squared over 4. Right? If I factor out 4 inside the square root, I will get 1 minus x squared over 4. Then that one, I can write like square root of 4, I can write like 2, right? And I can write like 1 minus x over 2. Right with me? Square root of 4 is equal to 2. And x squared over 4 right here, I can write like x over 2, everything is squared. You guys with me in this step? Okay, so if I have the square root of 1 minus x over 2 squared, so if I want to use the sine theta, remember like 1 minus sine squared theta. So my sine theta is going to be equal x over 2, right? So I just said x over 2 is equal sine theta, right? Because like sine theta here, I put in here, I have 1 minus sine squared theta. Okay. Then when I set x over 2 equals sine theta, I need to replace like x right here, everything in x become theta, right? So equal to sine theta. So what is dx? It's just 2 cosine theta d theta. Okay. On the last one, I can get like theta equal sine inverse of x over 2, right? And also this problem, I have the limit, the lower limit equals 0, the upper limit equal 1. So I need to convert to the new limit for theta, right? So if x equals 0, theta equals sine inverse of 0 over 2 is just 0, right? So what is the sine inverse of 0? It's just 0. when x equal 1 here, so theta gonna be equal sine inverse of 1/2. So what is the sine inverse of 1/2? Oh, pi/3 or pi/6? Yeah, so you have the unit circle. Okay, you have the unit circle. It goes right, we'll just we don't have to explain. So like I know like it's maybe confused with like the sine and cosine pi/3, pi/6, pi/4. Maybe you forget because I learned like a long time ago. That's why like when I try to test you guys, I just want you to know like what is the sine of 0, what is the sine of pi, what is the sine of pi/2, what is the cosine of 0, what is the cosine. Just like something special like 0, pi/2, and pi. Yeah. Then like if I test you, I will give you like the the value, right? So no worry. If I give you like this problem on the final, I will give you like I give you like sine pi/6 equal 1/2. So you don't have to memorize. Okay. Okay. So the integral now is become the limit now 0 to 1, right? 0 to 1 now become 0 and pi/6, right? The new limit. And also dx 2 cosine theta d theta. 2 cosine theta d theta. So we have 2 here, right? 2 here. So 2 square root 1 minus s/2 square. S/2 is sine theta. So it just becomes 1 sine square theta. So 2 cancel out, right? You have cosine theta d theta, and that one is just cosine theta also cancel out. So you only have integral of 0 pi/6 d theta. So that one is just pi/6. Okay, just pi/6. Okay, any question for this problem? If not, we can move to the other example, like the integral from 0 to 1/3. 1 over 1 minus 9x squared dx. Okay, so first of all, like which one we will use, sine or tangent? Sine, right? Because you have square root of 1 minus the variable square here. So for sure we will use like sine theta. Okay, so I can write like that become square root of 1 minus 3x squared, right? I can write like that. So I will set 3x equal sine theta. Okay, so x is equal 1/3 sine theta and dx equal 1/3 cosine theta d theta. And also for that one, I get like theta equal sine inverse of 3x. And also I need to change the limit, right? Because like 0 and 1/3 right here is for x. If I want to convert to the theta, I need to change the limit to the theta, respect to theta. So again, if I have x equals 0, so theta is equal sine inverse of 0 is just 0. So if x equal 1/3, so theta gonna be equal sine inverse. 3 times 1/3 is just 1. So it's just equal pi over 2. Okay, so it means the integral now is become from 0 to pi over 2. 0 1/3, 0 1/3 becomes 0 and pi over 2. dx is equal 1/3 cosine theta d theta. So 1/3 cosine theta d theta. And the square root 1 minus 3x squared. Now it should become 1 minus sine square of theta, right? So I can put here cosine theta d theta. 1 minus sine square theta. Now it should become cosine theta. So I can cancel out this one. So I only have 1/3 d theta, right? So that one it should become 1/3 theta. I evaluate 0 and pi over 2. So it's just 1/3 pi over 2 is just pi over 6. Okay, that one is easier than problem 3. The problem 3 I think is harder. The problem 3 you have to factor out 4. That's one like you have 1 here. You already have 1. You already have 1, right? But that one you have 4. So you need to factor out 4 to get 1. Because like when you use Trig substitution, we have like 1 here. Everything is 1, right? This one also 1. This one also 1. So you need to modify a little bit by factor out the constant, the number, to let that become 1. Okay, let's do one problem. One more problem for substitution. Like integral of 1 over x squared plus 16 dx. So what do you guys think about this problem? We use sine or tangent? Tangent, right? Yes. Because I know square root and you have like the variable square, you plus the number. So you have tangent. But we need number one here, right? But that one is secant. So we need to modify a little bit by factor out. Okay. S square over 16, I can write like S over 4 all of them square. But when I write this way, I know I should say S over 4 equal tangent theta. Okay, so S is just 4 tangent theta. So ds is equal 4 secant square theta d theta. And also for this one I can get like theta equal tangent inverse of S over 4. Right. Now the integral 1 over 16, I keep 1 over 16. The dx right here, it become like 4 secant square theta d theta. So 4 secant square theta d theta, right? And the bottom, I have x over 4 square plus 1 right here. It's just tangent square of theta plus 1. So I have 4 I divide by 16. So I have 4 for the bottom. Tangent square theta plus 1 from the denominator right here is equal to secant square theta. Okay, so I can cancel out that one. So that one, it should become 1 over 4 d theta. So it's just 1 over 4 theta plus c. And 1 over 4 theta is the tangent inverse of s over 4. So that one is the final answer. Any question? Any question for this? Because like in this class we only need to know sine and tangent, right? So the very first step you need to know like which one is using sine theta for substitution, which one is using tangent theta for Trig substitution. I think like it's easy, right? It's easy to see like when you use sine and tangent. Next problem is integral square root 4 minus x squared ds. So for this problem, we use sine or tangent. Sine, right? Yeah. And because like we want the number right here equal 1, not 4. The number right here is 4 is not good. We want number 1, right? Because like again we use this formula, so should be 1. We just need to modify a little bit by factor out 4. I mean, like, this problem is important problem. Because I think like if I test you guys, like the problem is too easy. Like the problem is too easy. But this problem is like something is, it's not too easy, but it's not too hard. It's doable, and it's like it has some like interesting step. So I will show you later. But like this one is like I think like, I like to test you guys this problem. So we factor out 4, we have like 4 times 1 minus x squared over 40x. So I can write like square root of 4 is just 2. So 1 minus x over 2 square dx. Okay. So from this step, I know I should set like x over 2 is equal sine of theta. Okay, so x equal 2 sine theta. And dx is equal to cosine theta d theta, right? And also, if I set s over 2 equals sine theta, so theta is just equal sine inverse of f over 2. Okay, now the integral is just become 2 square root of 1 minus x over 2 now is sine square of theta, right? This one equal that one, so the whole thing right here is just that one. dx is 2 cosine theta d theta. Right? dx is equal 2 cosine theta d theta. So I will have 4 1 minus sine square theta is equal cosine theta. And I times cosine theta d theta. So basically I have 4 times cosine square theta d theta. So how we can evaluate this integral? This is the even power, right? So the even power, so you need to only one way to evaluate this integral is reduce the degree by using double angle identity or reduce the degree. Only one way. So cosine square theta, I can reduce the degree by 1 plus cosine of 2 theta over 2 d theta. So that one is 4 divided by 2 is just 2. So I have 2 plus 2 cosine 2 theta d theta. Okay? So now I can integrate, right? I can integrate them. So integrate of 2 is just 2 theta. Integrate of 2 cosine theta E equal sine 2 theta. No, sine 2 theta n plus c. And because like the question give me x, and now I have theta, right? So I have to convert back to x. So theta is equal what? Theta is equal sine inverse of x over 2. So that one I have 2 times sine inverse of x over 2. How about sine 2 theta here? What is sine 2 theta here? Sine 2 theta right here, I can write like 2 sine theta cosine theta, right? Right. And sine theta is just equal, sine theta is just equal x over 2. Okay, so 2 times x over 2. How about cosine theta? What is cosine theta? In terms of x, that is a tricky part of this problem. So to find cosine theta in terms of x, you need to draw the right triangle. So for example, I assume that one is theta. Okay, because like I said, I said sine theta equal x over 2. Sine theta equal x over 2. And sine theta is equal opposite over hypotenuse. Right? The sine theta is equal the opposite over hypotenuse. So it means like I can set that one equal x, that one equal 2. Right? Because I think like from beginning, I set sine theta equal x over 2. And because if this angle is theta, the opposite is x and the hypotenuse is 2. Okay, so for this right triangle, I have one, the opposite equal x, the hypotenuse equal 2. Can I find this length? I should apply the Pythagorean theorem. The Pythagorean theorem is, I find that one is just 4 minus x squared. From Pythagorean theorem. Okay. So what is cosine theta? The cosine is equal adjacent over hypotenuse. So it just goes 4 minus x squared over 2. So it means cosine theta right here is equal square root of 4 minus x squared over 2 plus c. So I can simplify a little bit. I get 2 times sine inverse of x over 2, then plus x over 2 plus 6. So that one is the final answer. Okay, you have any question for this problem? I can repeat any step you still confused. No question? Okay, remember like this problem, like I say, is important. Yeah, I will likely test you guys this problem like similar to that on the final. Maybe I will test you guys the integral of maybe not exactly 4 minus x squared, but 9 minus x squared, or maybe I test you with 4 minus 9x squared. Okay. Any question about this lecture? Okay, if not, like, let me stop.